Are you struggling to choose the right chart to display categorical data distribution? In this video, we'll explore 3 must-know charts that will help you communicate categorical data insights using clustered, stacked, and 100% stacked bar charts where each has its own unique strength. Categorical data is common for data scientists when analyzing datasets. However, with just a few simple tweaks, your charts can provide more powerful insights, like revealing the top 3 countries with the highest child mortality rates. Stay tuned for practical coding tips using Matplotlib in Python and best practices, and if you have questions, drop them in the comments below. I'm happy to help. Okay, let's dive in. The first bar chart is clustered bar chart. It is a powerful visualization used to describe categorical or discrete data across multiple categories, where each category contains several subcategories clustered together for easier comparison. Let's take a look at the following cluster bar chart example from The Economist, which visualizes individual share percentages going to House Democratic candidates in different districts. First, multiple categories represent different groups of district areas, such as Democratic-held, Republican-held, competitive, educated, and diverse districts. Second, the subcategories within each category represent data records from different years, such as 2014, 2016, and 2018, adding an extra time dimension to the data. Therefore, the main highlight from a cluster bar chart focuses mostly on the subcategories from each specific category, which can be unique amongst other categories. For example, the individual share of contributions to House Democrats reached its peak in 2016 in Democratic-held districts. In contrast, 2018 saw the highest share towards competitive districts. Now, let's take a look at how this concept applies to a real-world dataset. We'll use the Titanic dataset from Kaggle and visualize it with Matplotlib in Python. Feel free to pause the video for clarity. In this example, we are plotting the survival rates of passengers in different classes across various embarkation ports in Cherbourg, Queenstown, and Southampton. First, after importing the right Python library packages, begin by loading the Titanic dataset and mapping embarkation ports from initials to their full names. Second, use the group B and unstack functions in Python to create a 2-dimensional summary table showing the survival rates, using the mean function on the survivors for each passenger class and for each embarkation port. Don't forget to reorder the class so that the first class is at the top. Third, create a clustered horizontal bar chart using Matplotlib to visualize the survival rates, with each bar representing a different embarkation port for each class. To make it look more professional, remove both the x-axis title and the grid lines from the chart, and use the clean white background. Fourth, add percentage labels of survival rates outside the bars using a for loop in a clear format. Don't forget to add the main title while removing redundant y-axis titles and adjusting the legend position. The cluster bar chart highlights the embarkation ports as the subcategories within each passenger class as the main category. Specifically, the bar chart highlights that Cherbourg Port has the highest survival rates, around 70% for first-class passengers, while Queenstown stands out for second-class passengers, with survival rates around 67%. Before we continue, if you found this video useful, don't forget to subscribe to my channel so you won't miss future tutorials and tips on how to apply data science and analytics in real business settings. Okay, let's continue. The second bar chart is a stacked bar chart. A stacked bar chart is a type of bar chart that displays the total amount for each category and breaks down the elements using stacked segments within each bar. Instead of representing a single value for each subcategory, like in a clustered bar chart, a stacked bar chart visualizes how each subcategory contributes to the overall total within the main category. Let's explore an example of a stacked bar chart that visualizes the total gas and electricity consumption across different European countries in 2021. In this chart, the subcategories representing various industries are not displayed as separate bars. Instead, they are represented as segmented sections within each main category bar, showing how each industry contributes to the total consumption for each country. The key takeaway from this chart is the total gas and electricity consumption per country, while the industry breakdown offers additional context and insight into the composition of consumption. We'll use the Titanic dataset again from Kaggle and visualize it with Matplotlib in Python. Feel free to pause the video for clarity. The code is similar to the previous code for a clustered bar chart, but there are some changes. In this case, we are interested in calculating the number of survivors, followed by creating a 2x2 table summarizing the number of survivors for different combinations of passenger class and embarkation port using the size and unstack functions. In the unstack function, the fill_value is set to 0 in order to replace missing values with 0. The plot function will display the stacked horizontal bar chart by setting the stacked option to true. The next goal is to add labels inside each stacked bar segment to show the number of survivors and also add a total label outside the bar, showing the total number of survivors for each passenger class. First, we loop through each passenger class to calculate the total number of survivors in that class. The variable width is initialized to 0, which represents the starting position of the first segment in the stacked bar. This ensures that the first segment will start at the far left. Second, for each embarkation port, Cherbourg, Queenstown, Southampton, we calculate how many survivors came from that port for the current class. If there are any survivors, where the segment value is greater than 0, a label showing the number of survivors is placed inside the corresponding segment of the stacked bar. The label is positioned at the center of each segment to ensure readability. Third, after placing the label inside each segment, we update the width by adding the segment's value. This ensures that the next segment starts at the correct position, stacking it on top of the previous segment. Fourth, after the stacked bars are drawn, we add a total label outside each bar. This label shows the total number of survivors for the current passenger class and is placed just to the right of the bar, ensuring it doesn't overlap with the segments. The label is vertically centered with the bar, displayed in black color, and has a readable font size for clarity. To make the chart look more professional, we add a legend to explain the colors representing different embarkation ports, a main title at the top of the chart, and remove any unnecessary x-axis and y-axis labels. Additionally, we make the x-axis invisible to avoid cluttering the chart. After running the code, you will obtain the stacked bar chart, highlighting the total number of survivors for each passenger class. For example, the majority of survivors came from first-class passengers, primarily driven by those heading to Cherbourg and Southampton. A 100% stacked bar chart is a variation of the regular stacked bar chart that shows the relative percentage of subcategories within a main category. It's useful for highlighting how the distribution of subcategories changes over time or across different groups. Let's explore an example of a stacked bar chart that visualizes the product market share from 2015 to 2017. In this chart, each bar sums to 100%, with subcategories representing product type distribution. This chart shows that market share from product A decreased from 32% to 22%, while market share from product B increased from 28% to 35%. Now, we'll use the Titanic dataset again from Kaggle and visualize it with Matplotlib in Python. The code is similar to the previous code for stacked bar charts, but there are some other changes. After creating a 2x2 table summary consisting of the number of survivors for different passenger classes and embarkation ports, the process involves normalizing the values using the div method. This ensures each bar sums to 100%, representing the percentage distribution of survivors across embarkation ports for each class. Then, we can use the same plot function as previously described when plotting a regular stacked bar chart by setting the stacked option to true with the horizontal bar as the chart type. Unlike a regular stacked bar chart, you don't need to calculate the total number of survivors in the for loop, as the focus is on the percentage distribution. The rest of the code to display the percentages is similar to the code for displaying nominal values from a regular stacked bar chart. Be sure to include a legend, a main title, and remove unnecessary y-axis labels for clarity. From the 100% stacked bar chart, we can conclude that the majority of survivors across all classes boarded from Southampton, especially in second class. In contrast, Queenstown is notably represented among third-class survivors. This highlights how the 100% stacked bar chart can effectively show the changing distribution of subcategories within each main category. By mastering clustered, stacked, and 100% stacked bar charts from the examples I've given, you'll be able to derive insights and elevate your data storytelling, particularly in visualizing categorical data distribution. In the next video, I'll be sharing a tutorial on how you can derive insights or uncover hidden patterns from numerical values using scatter plots and bubble charts. Thanks for watching.